And we are live. Live proper live. How's everyone doing today? Yeah. The agenda for today. Maybe I shouldn't say agenda. That sounds very meeting-like. I guess my goals for today are just to get the daily done and then hopefully get through all of part 6 of the kaleidoscope tutorial, actually. No worries, Prathy, you're just on time, actually. Yeah, ignore the packing mess behind me. For I have a flight quite soon. And by soon, I mean tomorrow. Not like today, but... I need to re-sign in, 1 second. I can just use Google. I forgot. 1 second. Alright. Yeah, I'll be flying back to school at least. So we'll have to see how my schedule goes. It's a morning flight, so I might have a stream, but it might just be like really short for what it's worth. 0 in okay. Given a 2D and then emphasize 0 index array. Okay, this problem seems fine. How many solved problems do you have? Let's see. Is it here? Yeah. Then this graph looks quite awful. Don't stare too long at it. Yeah, my problem count's quite low actually, so it's nothing really to brag. What is happening in this problem? So there's a vector in. Huh, okay. What would be the best way to go about this? This is just math, which I'm admittedly not particularly great at. I mean, surely just a standard for loop, right? Is there like a follow-up down here? No? Okay. Sure. Yeah, I don't know the math library too well. Let's see. Okay, it's just square root and pow, I think it was. This should be float. And area should be an int, actually. I guess res, we'll call it that. Is there something like tuple in stdlib? I think there is. Yeah. Yeah, this has been in for a while. Yeah. So I guess this does exist, but I don't feel the need to use it, so yeah. It's just so this is square root of power? Pow, okay. Pow of D0 to plus pow of D1 2. Okay, let's not reinvent the wheel here. This should be sufficient. Oh. Ew. Oh. So it should be this. What am I forgetting here? We have longest diagonal. Do I need to do like the floating point comparison thing? Yeah, they do wrap it in a class. I think they do that for everything as well. I assume it's just for runner related reasons. What am I doing again? And then else if yes, I know I need to change the comparison. Do people talk about this at all? Oh no. They missed this thing apparently. What does a good epsilon here? One E right now. 1E minus 5? Oh wait, this should go first actually. It just occurred to me. Uh-oh. I keep doing this? Wait, what's... Huh. Oh, do I never update max diag? Yeah. Then if res equals... Let's just compute this once, actually. Can I compress this all into one statement? Let's do some really gross code here, actually. So if this is true, and res is, or area is greater than res. Or diag is greater than max diag. And I need to add the braces back. Then we need to set max diag equals diag. That's still wrong. Huh. Why am I struggling with this one? I feel like I shouldn't be getting tripped up on this. Is there like something really obvious I'm missing? Oh, I can just compare the squares. Wait, that makes a lot of sense. Wow. And then that gets rid of any like float errors. Yeah, and then we can also avoid the function call as well. Wow. Okay, I feel a little bit silly for not thinking of that. Let's do that. Int max, int diag equals d0 times d0 plus d1 times d1, and then d0 times d1 if the diagonal is larger, so if diag greater than max diag, or if they're equal. And then area is also greater than max area. Eee. So then we set both. And then I changed this to max area. Alright, I feel a little bit silly for not realizing that I don't need to square root, but got it in the end. Let's see. Okay, yeah, this is sure. Okay, neat. Alright, moving on swiftly. Yeah, we're adding user-defined operators to kaleidoscope. Yippee. Yeah, we'll just go here. Yeah, okay. So we have a fully functional language with an asterisk. Doesn't have many useful operators. I feel like there's bigger problems than that one, but that is definitely a big problem, yes. Yeah, this is like literally all the comparison we have. We got some user-defined operators. Sure. Ooh, mandelbrot. Okay. Huh, wait, kicking the tires. That's pretty funny. Okay. Okay, so we get to do things with operator overloading, I guess. I guess even more generally. The point is to show the power and flexibility of using a handwritten parser. Okay. Hey Julian, how's it going? Good to see you in chat. Okay, so example unary operator is not, this is the operator, and then that's the definition, and then there's we're defining greater than because less than is the only comparator we have right now. Hey Nitro, how's it going? I am from the US. This seems like a pretty nice set of operators that I've very much missed using. So yeah, I guess I'll just get straight into it now. Okay, so we need to add binary and unary to the Elixir first. So let's go here. This is quite boilerplate. This is binary, unary. And then we need to change these values. And then get toke. This keeps growing, huh? Binary. This turns into binary. unary, unary. Yeah, this is pretty cut and dry. Okay, so we've done the lexer. Represent binary operators with full generalization by using the ASCII code. So you don't need new AST or parser support. We have to be able to represent the definitions of these new operators. Have to be able to represent the definitions of these new operators in that part. I don't know how to read that. That part of the function definition. And then the name for the function definition is parses the prototype production. I see. So we need to add more stuff to this. So we're adding these two, it looks like. And then we're adding this. Ugh. Oh. Well, okay. I mean, I guess sometimes you have to crack a few eggs to make an omelet. Yeah, let's go up here. Get name, get args, and then we need to throw more stuff here. Just move this up here. Actually, no. Maybe I don't do that. Need to add pool is unary op. And then is binary op. Is that all I need? Get operator name. Oh, and these are all const. Welcome back. Okay, so we've got the lexer. Oh, this is just the explanation. So we updated the lexer. Now I'm adding the updating the AST. We're implementing user-defined operators, both binary and unary. So for instance, like the not operator, or the greater than comparison, or binary or, for instance. Even equals. That one's pretty important. Okay, so I think that's all these get binary precedence. That's what I'm missing. Yeah, the syntax is kind of just permanently doomed from what I've been gathering from this, but it is what it is. Oh, I need to add the private fields. Yeah, I feel like, at least with like these sorts of introductory languages, they're always more about just like getting used to I guess the infrastructure behind them rather than focusing on language usability. And I guess that makes sense, just at least in terms of like a beginner friendliness perspective. Okay, so we've added the private fields. Okay, we need to actually implement things now. There's the constructor, get name, get args. Where's CodeGen? Oh, there's CodeGen. Okay. So these all go above here. Okay, so let's go Word. Let's insert prototype AST component. And then let's go to the end, delete that. Oh, I forgot to after. There we go. Wait, no. Wait. What am I forgetting? C. There we go. This was not worth it. I'm just gonna do this by hand. Big loss for all the Vim enjoyers, unfortunately. Okay. What are these implementations? Is unary op, return is operator, and args.size equals 1. Okay. And then this one is 2. And then operator name. So we pull out the assert block. We reuse code. What did I do here? Is binary unary op. Great. There we go. How do you say your username? So it came from golf1, and then I accidentally typoed a D onto the end, and I thought it sounded better, so it's golf1. First grade me was... I can't say smarter than current me. Yeah, name was a field. I forgot about that. And then the last character. That makes sense. Yeah, that works. It doesn't... I don't really care too much about how my username is pronounced. Okay, this seems all nicely implemented. Nicely being a relative term. So we keep track of whether it was an operator and its precedence, and then there's some helpers. So we have the AST, so now we get to fix the parser. Oh boy. Parse prototype. Oh. Okay, what is happening here? Do you game? Yes. Or at least I used to a lot. I played a lot of Valorant previously. I don't really play too much of anything anymore, though. Where does this live again? Parse prototype. There we go. Oh, this gets really ugly now. Okay. So let's steal the boilerplate, or let's steal the declarations at the top. Let's give binary binary precedence. It's 30. Is 30 the default? I guess it is. What does parse prototype do? This handles like the literal. I guess the easiest way to describe it is just like the function, like. It's not really like the. I wouldn't say signature, but I guess yeah, function prototype. So it's like this thing, and then it's this thing in the function defs, and it's also the same thing in the function calls, I think. Wait, no, not in the calls actually. It's only the function definition. I guess maybe signature is the right word here because they all return doubles anyway. So it's like the function signature prototype header thing in externs and in defs. This is the wrong file. Oops. Okay. Yeah, all functions return double in this. Presumably just like keep it simple for now, but I don't imagine it being that much different to just add more types at least. Like it's all the same process. Oh, that's not the right button. So now we have a switch block. That's gross. Switch on Kurtok. Let's give it a default. Let's move that there. Yeah, everything's a double in this. It's a little bit confusing to me, actually. It feels like surely int is like the default type that people. Actually, I guess it doesn't really change the way it interfaces with LLVM. Like just instead of calling double, you'd call like int, and it'd be like, okay, cool. But I guess it makes sense why. So we need. What's the default case? Token identifier. Okay. Oh, I changed the name of this. Okay, let's steal this. Let's put this in here. So we get the identifier value. We set kind to 0. And we get next token. And then if it's a binary, then we does this not handle unary? Oh, we add them later. Okay, sure. I guess that's fair enough. So we eat that token, then we check if it's ASCII. It is. Where does this come from? From the CC type. Okay. Kurtok. Then we error it, I think. Yeah. And this comes from prototype. So we expected. So do the operators work globally? I guess yeah, it would work a little bit like a extension of operator overriding. Um, yeah, I guess you could. I guess the best way to think about it is just like being able to define operators with the additional benefit of being able to override the existing operator, for better or for worse. Um, okay, so we call the function binary. Oh, binary and then the thing. And then kind equals 2. Okay. What is kind? Oh, that is kind. Nice. Okay, that makes sense. And then we set precedence. Also I forgot to add a breakup here. Name equals binary. Cast this to char. And then the type it is kind 2, and then we get next token. Then we break. Oh wait, no, we don't break yet. We read the precedence if it exists. It's a number type. Get numeric value. Let's save this somewhere. What type is this? Let's get rid of that so I can. It's a double, okay. We could probably cast it to an int even. No, clang D is still working. It's just I think it was getting caught on the incomplete if or the incomplete declaration up here. Cur? Yeah, let's call it cur. Oh, val. Let's call it val. Log error if it's not in bounds. That's good enough. And then we set precedence. Oh yeah, this is the one, yeah. And then we set this to we cast it again. Okay. And this is val. This is some of the less pretty code I've written in a hot second. which is really saying something given the mess that I made last time. And then here we break, finally, it looks like. Right? Yeah. This alignment is confusing me a little. Oh, I see. Yeah, this makes sense then. Did you start programming in college or before coming to college? I took a couple of AP courses before showing up to college, but I didn't really do much else besides that. And then I showed up at college, and then I started. It actually took me a while to start programming, like real language programming. Because I used Bracket for a little bit for one of my classes, if you've heard of it. It's like a functional language that's mostly used for research. A lot of PL people really like it. And then of course our engineering intro sequence was in MATLAB for some god awful reason. So I had a little bit of that as well mixed in, but that's always how it goes, I guess. So let's actually keep that delete there. So Git is happier. And then what am I missing? The rest of this seemed fine actually for the most part. Oh, but I need to add things to this. Oh, and then I need to verify, yeah. So if kind is not 0 and arg names, not size, not equals kind, then return. So much error handling, which makes sense. I guess I'm not used to seeing this many, this much, like, error handling. This feels more robust than what a parser generator would vomit out from the little bit of that I've done. So this is name, we keep arg names, and then we pass in oh, I see, that's a boolean, yeah. So kind is not 0, and then precedence. You're doing masters? Yes. Let's get rid of that. Oh, did I forget to adjust the constructor? I think that's what I forgot to do. Yeah, I was supposed to do that up here. Yeah, okay. Whoops. Yeah, and then we have default values, so I think that's perfectly serviceable. Yeah, okay. Do default values go in the header? Interesting. Oh. unless you are being naughty. This compiler adds default arguments when it compiles the code that calls the function. It won't matter what the defaults are in the CPU file. Interesting. Ooh. That's crazy. You can get it to generate different defaults for different calls. Okay. So it does go in here, which makes sense the more I think about it. So we need to adjust this. And then bool is operator, and then unsigned precedence. Okay. Wow, we're really getting close to the 80 column limit. Okay, so then that's done. So then this should be fixed. Looks like it. LSP's not yelling at me. Okay. Interesting part about the code above is the couple lines that sort of function name for binary operators. This builds names like binary at for a newly defined at operator. Then takes advantage of the fact that symbol names in the symbol table are allowed to have any character in them, including embedded null characters. Wait, I do that? Wait, what? Huh? What? When does it do that? I don't know. I'm not gonna think too much about it. Next interesting thing to add is code gen support for those binary operators. Sure. Given our current structure, this is a simple addition of a default case for our existing binary operator node. Okay. So we have this stuff already, if I remember correctly. But then we have to handle default differently, if I remember. So this still goes here. Okay, here it is. Oh, there we are. Forgot about Control U, Control D. Okay, so we have to change this to break. Yeah, there we go. And then, so now we set F to get function. yeah, this is a thing. Stood string binary plus op. Yuck. I'm not sure why we're switching between asserts and the like log error thing, log error v, and just like if statements. But I mean, like, I guess it's not that bad. I want to use more asserts in general. Okay, so now okay, so then value what type does this make? Oh, these are lowercase. Oh yeah, I guess that makes sense. Okay, so then return builder, create call with a big C. Yeah, my biggest mistake here is definitely not following the LLVM style guide, because now I have like mixed variable casing, which is really starting to irritate me, but it's a little bit too late to go back. So just does a lookup to the appropriate operator in the symbol table and generates the function call to it. User-defined operators are just built as normal functions. That makes sense. Okay. Oh, I see. Okay. And then, what are we missing? Before codegenerating a function, if it's a user-defined operator, we register it in the precedence table. Oh, I see. This allows the binary operator parsing logic if we already have in. Oh, I can't read. This allows the binary operator parsing logic we already have in place to handle it. Since we're working on a fully general operator precedence parser, this is all I need to do to quote-unquote extend the grammar. Okay. So, oh, I see. So this would go in CodeGen, it looks like. Function AST CodeGen. Here it is. Let's see, this is fine. Install. Okay. And then should do it down here actually. I think. Yeah, because these are all checks, I think. I think we just say that we can't redefine functions and call it a day. I think that is the most sane way to go about this from a design perspective. How does the operator thing work in LVMR? So I guess it's more. I guess the short answer is that it works through indirection, which is, I guess, how all programming language theory is constructed. The idea is that we're just treating them as standard function calls, as just like standard user-defined functions, but we're calling them with when a different thing is parsed, pretty much. So on the parser side, it's treated as an operator, but on the LLVM side, it's treated as just a function call, is what I'm understanding. And that allows us to just like have arbitrary logic as the operator logic. So instead of having like, or I guess the way equals would be treated is just literally is literally in like a binary equals function that takes in left and right, and then it returns a double. Yeah, it's I mean I don't even think it's that bad the more I think about it. Like this is kind of just the standard programming languages, smoke and mirrors. Oh right, this thing, that's where we are. So if we made this neat little helper. Where did binary operator precedence live? It's in here? I hope it's not in here. Oh, it's in here. Oh boy. All right, we have to global this, I fear. What do we even do with this? What are the operators we have? It is these four. And then bigger number is higher precedence. Where do we even move this thing though? This is defined here. Just in here. What do I want to do with this? I guess I could just extern this even. Does that make sense? Yeah, at this point, this LLVM file is getting a little bit unwieldy with globals. So I'd like to avoid putting that there as much as possible. But I may just have to put it in. I could even put it in runtime. It would like kind of make sense to put it in runtime, but not really. I guess I could put it in AST technically. Sort of. Doesn't really make sense. Is there a circular dependency issue here? I think it makes more sense in AST the more I think about it. Let's take this out. Why not make a header? Honestly, yeah. It's still a little bit, it feels a little bit not in the spirit, at least at a glance to me. Yeah, I'm just gonna throw an AST and call it a day. I think that might be the least ugly way to go about this. And then let's do that, and then we have to extern this. Place this here. I feel like this is improper. I feel like this was just a deficiency in my C++ understanding. Okay, this makes sense, roughly. We declare extern on the header, and then we define it in the source file. Okay, this makes sense. This seems about right, roughly. Yeah, okay. Okay, this roughly checks out to me. So then in here, do we need to stop it from... I feel like it needs... Do I need to import the header in here? Where did I tear this from? From here. Oh, I guess it's already imported. So it's technically already imported in whichever one of these imports AST. Parser.h imports it, definitely. So I guess we can get away with not importing it? It's a little bit... That's a little bit unparadigmatic. But I mean, sure, we'll work with it. So let's clean this up real quick. So bin op precedence at p.get operator name is p.get binary precedence, and then the rest we can reuse. Can anyone explain what the compiler role is? I guess just at a high level, just a job where I can work on compilers. I don't really have that formal of a definition. I'm pretty loose with the definition. Unfortunately, very few internships exist for it, so that's a little bit unfortunate, but it is what it is. Well, nothing's broken yet. Let's give this a try. Def binary. Let's make this, let's do OR for now. This is precedence 5. Have you considered Google Summer of Code? I have, but I feel like at that point, I don't know, it feels less, if not equally as valuable as just doing research over the summer for our compiler group, which is definitely something I could think about. But I feel like just having like a proper internship is more resume valuable, at least. Ugh. Yuck. If LHS, then 1, else if RHS, then 1, else 0. Okay, nothing's crashed yet. So then 0 or 0, evaluates 0, 1 or 0, evaluates 1, 0 or 1, evaluates to 1, and of course 1 or 1 should evaluate to 1. Yeah, the semicolons are like a slap in the face. Like yeah, we don't need braces. We don't need colons to like define functions. White space isn't significant, but let's just throw in the semicolon. I guess the semicolon is like kind of necessary if white space isn't significant, more so than braces, but it's like, it feels like a bit of an afterthought almost, I guess, which is kind of funny. Let's define and. Ooh, we could recursively define it with this. Actually, that's overkill. Def binary and then same precedence as this. Oh, okay, wait. If LHS, then if RHS. Then 1, else 0, else 0, else 0? Okay, this looks good. So then 0 and 1. 0 and 0, 1 and 0, 1 and 1. Okay, well that works. Why do you like compilers? I think the stuff they do is magic, and I also really like optimizing things. So it's kind of just like a perfect fit, honestly. I mean, like the entire if-else chain is one statement. Yeah. this else 0 stuff is pretty funny. But yeah, it looks like that works. So I guess now we go to unary operators. Oh wait, that sends me back up? Okay. What is kicking the tires? Oh, this is the mandelbrot example. Okay. Okay, so we need to add a lot of stuff. Youch. Okay. So we already did the Lexer, so now we add the AST node. Ugh. Okay. And we need to add these because why can't we just reuse the function? Oh, right, for like actually evaluating them. Okay, that makes sense. So we can reuse the prototype for like the literal declaration, but in terms of how we're gonna code gen them, we don't have a thing that supports unary operators yet, so we need to add that as a thing. Similar to how over here we have binary expr AST. We need unary expr AST now. So let's add this. How much of this can I copy? Yeah, let's get aggressive. So let's change this to unary. Let's change that to unary. We can keep odd up, and then we need to change this to operand. Delete this even. And then yeah, so that seemed simple enough at least. This is a little icky, but that's fine. This should be operand. That. And okay, that should be repaired. Okay. I just realized I forgot to run the formatter on these. Okay. This AST node is very simple and obvious by now. It directly mirrors the binary operator AST node, except that it only has one child. Sure. Parsing is pretty simple. We'll add a new function. Sure. The only interesting thing that I think about is how parse primary will end up working. The rest of this is all pretty boilerplate. So we go to parse binary. Oh wait, it would have to be amongst this list. Number, parent. I guess we just put it with this here. This is parse unary. Wait, no, that should go down here even. Because all of these are expr. All of these are appended with expr, so let's not split up the family here. So where did I put this again? I literally just said where I put it. It would have to be after primary or before primary? Before primary, okay. I know it doesn't matter, but I'd want it to look a little bit nice at least. So let's just steal this. Hey. What the? Okay. And then okay. So if it's not an operator, then it's a primary expr. So if it's not ASCII, or it's a parenthesis, or it's a comma. Per toke equals opening parenthesis, or per toke is a comma, turn parse primary. What's mad here? Oh, I can't spell. So then if it's a unary operator, then we read it. I guess that makes sense, yeah. What is this supposed to be? Op char, I guess. If you're still here on stream, thank you for showing up. While I'm just typing away at this, make sure you've liked and sub to the channel. So we eat the token, and then okay. So then we parse inner, and then we make the thing. So we go all the way down, and then we traverse back up. So we parse unary again, and then we move the operand. Otherwise, return null pointer. Okay. So we just process it. We read it, we process the inside, and then we process it on the way back up. So now we need to call it. So we change parse primary in this parse expression in the whatever this mess they called it was. Binorfs. In my stuff, I called it parse expression and parse expression rest, which I think was a pretty sane way to name it. So we replace this with parse unary. And then here we replace this with unary. Let me just make sure there's no more of this in here. Okay, those are the only two uses, which means we're doing good. Yeah, so I think that's all the changes that we need to make. Oh, I lied. We need to do that. We need to fix the prototype parsing, because we only did that for binary ops. So we add to this slush pile. Maybe I should just make a parse. No, because then I have to like pass around this stuff. We're finishing early today? We'll see. We'll see. There's always a chance for something to segfault and for me to miss it for 20 minutes straight. You never know. I'm quite notorious for that, as a matter of fact. So I wouldn't put it past me. Sig core dumped. Like if I left token binary in here, for instance, that would be catastrophic. So we eat the token. Oh, we kind of just do the same thing as this. Okay, well. Yeah. And then we don't have to worry about precedence because this is just a unary operator. So this is fine. So expected unary, let's rename this to unary. Let's keep doing this messy thing. But then kind is 1 because it's only 1. It's half as kind as binary. What am I saying? No. In case you missed it, since I think I did binary at least like half an hour ago, what kind does here is I guess it's the flag for whether it's whether the function is just like a standard, just a standard function, or if it's a unary operator, or if it's a binary operator. Why don't they use enums or something for kind? That's a good question. I assume they don't really. It's one of those things where you don't really need to over-engineer it. Like, I think it's fine just to have a simple flag with a comment here, even if it detracts from readability a little bit, especially since this is pretty much only used inside this function at least. So, like, you could make, like, yes, you could make a enum, but it's also like, we don't really need to reinvent the wheel here. What did I forget to do? We need to cogen. So this should be good. And then cogen lives in AST. We have this, and then we need, not in here actually. It's in function AST cogen. Wait, no, I'm tripping. Wait, no, I am tripping. It does go in here. Is the tokenizer, I'm following this tutorial by LLVM, which is, oh, this just brings me straight to where I was. It's the first language front-end tutorial. So what we have here, and also this is a bit of an explanation for newer viewers who haven't watched, I guess, like the past week or so-ish. I don't remember how long I spent on this, but so we have this language here called kaleidoscope, and it's a pretty simple language. It's not really syntactically complex. It's just like a couple of simple tokens. So like this is just a standard recursive Fibonacci function, and the goal of this program is to read in these functions and then turn them into LLVM's middle end code. It's called LLVM IR, which is short for intermediate representation. And the idea is from there we can just use the rest of LLVM's infrastructure to generate assembly. So what we've done so far in the tutorial is we first made a lexer, which has various token values, and it reads in the input, and then it interprets what it is. And then we wrote a parser which takes those read in tokens and turns them into a memory representation of the program. So the way I explained this at first is that the lexer is sort of reading words, and then the parser takes those words and forms sentences out of them. Of course, it's not like literally words, because there are like other things to worry about, like operators and like numbers, but you can kind of think of them roughly as words from just like an abstraction perspective. And then the memory representation that we've built is under AST here, which stands for Abstract Syntax Tree. I think there was an example AST somewhere in here. No? Okay. I guess I've provided misinformation. But yeah, it takes the program and it basically turns it into a memory representation, which then we can traverse with just like standard tree traversal algorithms. And then the code gen is handled with the relevant code gen functions within the AST. So each node has its own code gen function that we call. And then like other small, we've like added a bunch of small things here and there. Like we've added if statements, we've added for loops. Currently we're adding user-defined operators. So we're allowing users to define like multiply and divide and like greater than, for instance. And then there's like some other small things, like we've added support for LLVM's optimizer to make the code more performant. And then we've added JIT support, which is short for just-in-time, as in just-in-time compiler. So after it reads in code, then it automatically takes that and generates an executable out of it, pretty much. So that's like the really dense or either fast or slow, depending on what your opinion of it is, overview of what I've done so far. Today I've implemented user-defined binary operators so far. So operators that operate on two different variables. And currently I'm working on unary operators, which is just like, an example is like the not operator, which just takes true, turns into false, takes false, turns it into true. Yeah. I'll leave the tutorial link in the chat in case anyone wants to follow along to some degree. And then my current implementation, after every stream I push to GitHub. So yeah. Wikipedia has a nice representation. Ooh. Oh, that's the wrong one. There we go. Yeah, this is a good example. Thanks for pointing that out, Frothy. So, yeah, so this is like the top level node for like sequence. So we have a while loop here, which is represented by this section of the tree, and then we have a return here. So the while loop has a condition and a body, and then that handles, and then each of those is like defined as its own thing. I think if you were to stare at this for long enough, you'd probably be like, yeah, I guess that makes sense. So I'm not gonna like dwell on this too long, but yeah, you could look this up on Wikipedia yourself as well if you were curious about, I guess, like the formal shape of what one of these would look like. So we're pretty close to done with unary operators actually. All we need to finish here is we need to handle code gen for them. So we've figured out we've defined what the words mean. We've formed sentences, but now we need to, I guess, take those sentences and turn them into machine code. I guess the analogy breaks down a little bit there, but that's like roughly what's happening. Yeah, okay. Wonder if I can just steal the binary expr code gen to some degree. How much setup is needed for the REPL feature? That I believe is the default implementation. As in, like, that is how the parser is implemented, at least. And then the file input stuff that I've added on top of that is, well, on top of that. But it's not that much actually if you have most of the parser tree traversal set up. Yeah, I have it at the top here. Or not here. This is the AST. Yeah, it's this parser run function. Yeah. And then like the tutorial has like all of these function bodies moved into their own helper functions, but I was lazy, so I didn't do that. Yeah, it just parses, like, it reads the first token. Based on that, it figures out which parser sub function it needs to call, and then it parses the whole AST, and then it calls codegen. Pretty much. Where did this go again? There it is. Okay. Unary, expr AST. This should return an LVM value. Value pointer, actually. Big V. That's what I'm missing. Yes, every node has codegen, and it is called recursively to my knowledge. Let's go down here to look at an example. So this codegens every single. Actually, this one's not a clean one to look at. I guess a lot of these are a little bit messy. Actually, yeah, all of this is like kind of a mess, to be honest. I guess prototype might ironically be the cleanest one here. It should be called somewhere here. Or function, yeah, it should be called, an example is in function. Yeah, ignore me stumbling around in Vim. So, so we find the relevant function, which I believe is already cogened. And then this would be easier if I just look up codegen. Yeah, here for instance, we recursively call cogen on the body. Yeah, and then like with the binary expressions, we cogen left and right recursively. I think there's a reason it was named kaleidoscope. It was somewhere here. Beautiful form and view. Beautiful is, I wouldn't call this language very beautiful or very formful. I definitely can see it, so it definitely gets the view part correct, but I think this might be a little bit of a stretch. Yeah, it is like based off of the toy though, which I guess makes sense. Maybe that's why it's a toy language, because it's a toy. Or I guess it's called that because kaleidoscope is a toy and it's a toy language, and it's like, yeah, sure, but yeah. Before I get too sidetracked, I should get back to finishing this mess. That shouldn't be that long. So we cogen the operand, and then we wrap it with a function. Cool. Great. that seems straightforward enough. So operand value. This is LVM value. So you cogen that. Who knew I had binary in the paste? So if operand doesn't exist, or if the cogen fails, it'll return a null pointer. So we're gonna check for that, and then if it is a null pointer, then we also return a null pointer. And then now we get the wrapper function. So get function. So the way we've decided to name these is it starts with unary, and then it includes the literal operator symbol. So we have unary plus opcode. What did we call it? Op. And then if this doesn't exist, then we return a null pointer, but we also want an error message with it. So that's what this log error v thing is. So at this point, then we have the function, we have the operand. Now we just need to put it together. So now we create the call with this builder, which generates it generates whatchamacallit. It generates the LLVM code. Yeah, that's big B because I was inconsistent. So this takes in operand V and then unary op. Oh, why did I make that big L? Okay. Yeah, okay. Unlucky me. Yeah, that one really sucks. Capital U. Nah. I don't particularly care. Yeah, that should be it for unary operator. So let's rebuild this and then let's test it with just like the not operator. Build times are slow, so it goes. And there we go. Okay. So let's run it. And then let's steal this not operator. So not. It takes in a value. Let's just one line this. That's not ideal. I compiled Cling from source on MacBook Air and had to leave overnight. Yeah, that's unlucky. There was a point last summer when I was compiling Rust from scratch, or from compiling Rust from source, and it took quite a while, because every time it compiled, it would use that to I guess optimize itself. So it would recompile from source like 3 times, which is kind of funny. Where did I mess this up? Error expected binary operator. What? Why is this happening? Oh, I see. Forgot to break. Alright, now we have to wait for everything it depends on to also rebuild because of that. Oh, that was actually quite fast. Even Java moved on from the break switch statements. Yeah. It just seems very unintuitive. And then you look at it and you're like, why? I mean, like, it is what it is. I assume it has like its benefits. Okay, this defines not 1 is 0, not 0 is 1. What would be an interesting thing to not? I can't think of anything interesting to not. Yeah. So this works, at least facially. If there's a bug, then like we'll tackle it when that comes. But now we get to do the section titled Kicking the Tires. So we can now add a nice sequencing operator. So let's print D. You're not a function call, that's a good call. Let's do def foo. Let's take an x and return x plus 1. Let's do not foo of. This is not a very interesting example. So let's do foo, not foo 0. So we expect foo 0 to return 1, not return then to 0. I guess not foo of 10. I guess would also do the same thing. Not foo of -1. Oh right, because negative numbers aren't a unary operator. Yeah, okay, that makes sense. We have multiplication defined, right? So you can def unary minus. Let's see how this breaks things actually. I'm curious. It's defined as 0 minus v minus 1. Okay. So what happens if we do 1 minus... Let's do 10 minus 1. Let's see if this breaks. It doesn't break. 10 minus -1? Okay. Somehow this is working better than I expected it to. So now we can go back here and then run not foo of -1. And this should evaluate to 1. Nice. Okay. So let's... Does this do we have print D? Or do I need to add it? Next turn print D x. Okay, so print D doesn't exist. But we have our little runtime library that we wrote last time, which I need to look back at because I forgot. So it is just print. Next turn print x def we had the colon operator. This is, I'm just gonna copy this. Oh, this is like the continuation operator, I guess. So print 1, print 2, print 3. Okay, nice. Maybe I should add print line as a thing even. That might be nice. This shouldn't be that long at least. Just do that. And then... yeah, it's in this window. We need to rebuild it. It's a pretty fast build, luckily. So, okay. Next turn, print line. And then binary colon operator. So now we can print line 1, print line 2, and then print line 3. Nice. So that works as intended. So now we add this whole pile. So what if I just paste this in instead of typing this in by hand? Oh. Oh, wait, this is literally the same thing. Okay. So let's just not there. Okay. Ignore that. Let's paste this in this time. And then extern print line. You can put in a file, right? Yes, but then it just returns after it executes. So that doesn't quite do what I want it to, I think. I guess it's worth a shot. But I'd have to like put everything in the file. Let's put in test. Test mandelbrot. Let's just paste that mess in. I think that's all we need for that, at least. And then put. I think this uses put char. Oh wait, that might be a nice one to implement even. Just like put. This is runtime. Yeah, this is a little bit gross, but let's steal that. Let's put it here. And then char c equals char of val. And then f print f put out. And then this is I think C. And then extern put x. So this 32 should be a space. Ah, there's the space. And let's put flush is a good call, yeah. Whoops. So then extern put x 46 43. So this should be a dot and then a plus. Yeah. There it is. Okay, so this implementation is fine. So now let's go back to mandelbrot. And then extern put x, and then, yeah, should be good. So we stole all of this. These are operators, sure. And then let's steal this. Of course. Yeah, we left theft here. And then... okay. Now we can steal this. Determines the number of iterations it takes for a certain function to diverge. Yeah, we can steal this as well. And then we can steal all of this. Yeah, this is absolutely overkill, but it's fine. Yeah, okay. Okay, let's see how this goes. Oh, I need to call it. Oh, that's a little bit annoying actually. Let's see if it prints at least. Let me just make another test actually. Test print. Yeah. Let's... yeah, that's the only change, and then I think all of this should work, so then let's steal a runtime library. Let's put it here. And then def foo of x. Let's make this a for loop. Zero, I less than 10, in. And then, what do you want this to do? Let's print line I guess. And then let's call foo x, or foo. We don't even need the x in here. Oh, I need to pass in the thing. Okay, so it does print actually. So now we can let's do a little bit more theft. As always. Oh boy, this is gonna be fun. Yeah, that definitely works. Yeah. This might resemble a certain mandelbrot fractal that you've seen before. Looks pretty good to me. Given that's probably generated from the same thing. That's really cool, actually. It never occurred to me just how cool this actually is. Let's see, can we... yeah. I don't think we need to reinvent the wheel and test more of these, but yeah. It's a real and powerful language. I guess that makes sense. It does what it needs to. It may not be self-similar, but it can be used to plot things that are huge. So yeah, that is user-defined operators. managed to get the whole chapter done in one day, which is definitely new for me. Maybe it's just because like this is a little bit less complex and we laid all of the groundwork already in the previous ones. Because like if statements, we generate basic blocks for the first time. For loops, there was a mess to parse through, both by hand and by eye there. And then like everything else we were like building from the ground up. But I guess this was the first time where we took everything and we pretty much just like directly extended it without too much complication anywhere. So yeah, next time we will add support for mutable variables, and yeah, that should be fun. So yeah, I think this is about where I'm gonna call the stream for today. I have to pack because I get on a plane to head back to school tomorrow. So yeah, thank you all for being here. Make sure you like and sub. I'll schedule. I'm not sure what tomorrow's stream will look like yet. I'll schedule something, but there is a decent chance that that it gets moved or something. That gives me a perfect excuse to make a post, I guess. So keep your eyes peeled. Yeah. If you know anyone that can refer me to any compiler positions, please send my resume their way, and make sure you connect with me on LinkedIn and add me on GitHub. So yeah, take care all. Take it easy. I'll push this code after I end stream.